Hello everyone, my name is Peshawa Mohammed and I'm a PhD student at TU Dublin. My presentation is about integration of BIM and GIS for urban transformation and creating digital twins. I have to say thank you to the DREAL, Digital Enhanced Realities, which is part of SFI, for supporting this research. So what is digital twins? If we look into literature, we see that different researchers provide different definitions for digital twins. However, the definition that probably stands out is the one provided by Michael Greaves, who was actually the first one who used the term digital twin. This is back in 2002. Greaves defines digital twins as a virtual development or representation of a real system or world. There are three main elements of digital twins. The physical product, which is in the real world, then the digital representation of that product in the virtual world, and the data that combines between them. Recently, we see that the digital twins are being applied in various domains, such as in manufacturing or in energy or even in healthcare sector. But digital twins can be created for cities as well by combining numerous and different sources of data. So BIM and digital twins are not the same, even though there are some similarities between them, but actually they are quite different. BIM is usually applied at the initial stage of the project, usually at planning, design, and construction phases. But once the project is constructed, then we can create a digital twin for that specific project, and it can be used for monitoring, maintenance, or optimization purposes. And what is GIS? GIS stands for Geographic Information System. It's a computer-based tool for creating, storing, analyzing, and presenting geographic information about real-world features. We can say any discipline that uses maps probably uses GIS as well. And a geospatial digital twins represents the building within the context of its surrounding. So why do we care by integrating BIM and GIS for creating digital twins? Well, one of the factors is we want to make our urban environments more sustainable, because if we have data from BIM and from GIS and from other sources, then we can make analysis on those data and produce simulations that would help us to make better urban planning decisions. One more factor is in the last 2 decades, we see that the population in urban areas is increasing drastically, and actually it exceeds the population in rural areas. It is estimated that there will be around 6 billion people living in urban areas by 2050. So this rapid urbanization and lack of available land in urban areas force decision makers to take advantage of space above and below ground. That's why we start to see more and more complex buildings all over the world. However, one of the disadvantages of having those complex buildings is their registration, because the conventional 2D land administration systems are not very efficient in order to store all the legal geospatial ownership information, especially for complex buildings and infrastructures. In the first photo from left, you can see we have a multi-story building, and in order to store all those information, we need loads of PDFs and 2D plans with limited visualization. Or in other cases, you can see in the second photo, we have a building that's actually passing over other buildings, or maybe we have infrastructure passing over other land use cases. That's why the 2D conventional land administration systems are not very efficient. I have to mention that land administration systems at Ireland, it was called Land Registry before 2010. Then it was changed to Property Registration Authority after 2010. And now it has been merged with Ordnance Survey Ireland and also the Valuation Office to form the CitA Ireland Authority. So how we better plan, design, and construct our urban areas and infrastructure in a more sustainable way for the future? And the answer is we must change our ways. And the solution, instead of using 2D land administration systems, we can use 3D. In the first photo at the top, you can see we have an apartment and we have a car parking area and storage using old method, just 2D plans in order to store that. At the bottom, we have the new way, which is we can use 3D models in order to store those information and then associate that with the specific owner and save that in a digital database. So there are multiple advantages actually for the new way, but among them, of course, the new way is digital. It's comprehensive. It can be used for very complex situations, and also it's very useful in urban areas. Whereas the old ways, in some countries, still they are using analog and simpler, and they're usually beneficial in rural areas. So this is the 3D LAS at the floor level, in which we can divide each apartment unit into different units, each belonging to a specific owner. So we could have two models. One of them is the physical model, and the other one is legal model. And the 3D LAS can be applied at a city level. Then it can be used for urban planning and development applications. It can be used for land use and zoning. But also, if we have those models and we can combine that with owner information, for example, the age of the person who's living in that buildings, then we can use it for other applications, such as in healthcare, or maybe in public safety, or maybe for energy management. So actually, if we have that, the way it is predicted in the literature that it can be used for smart city applications in the future. This is just a screenshot from Uppsala municipality in Sweden. They are actually using some sort of this 3D digital twin with not full functionality, but they are using it for many purposes. And also there is a new project that's funded by EU. It is for converting the digital building permit into automatic, again by using this method, 3D LAS method. The 3D LAS is not a new concept. You can see on the map the green markers are countries that are already using 3D LAS, and orange markers are the countries that are implementing or testing 3D LAS for their local cases. And in order to do that, of course, we need data from BIM, most importantly, the 3D building model, and also building attributes. And from the GIS side, we can combine it with topography, utilities data, geospatial data, land use, land cover, and parcel data, and so on. So combining and integrating data from both domains, we can create a comprehensive model for the digital twin. And it's also important to use the open data for increasing interoperability and meeting the EU data directives. IFC is one of the most common open data formats in BIM that can be used for sharing data within BIM environment. CityGML is a 3D GIS format that can be used for sharing the GIS data, and Land Infra is a new OGC standard that can be used for sharing the geospatial data. As you can see, each format is designed for a specific purpose, but if we can combine and integrate those models, then it could have substantial benefits. So my research started with conducting a literature review over actually 5,900 papers were reviewed. I used Web of Science, Google Scholar, and Scopus. Then the papers were narrowed down and filtered by reading the abstract and the titles and removing irrelevant papers. Finally, 148 papers were included in the research. And this is the citation per year, starting from 2012 to 2023. That those papers that citing BIM and GIS integration. 2023 is very low because actually this graph is from a couple months ago. That's right. And this is the journals with highest ranking in BIM and GIS integration. So I find out that there are four main integration techniques that research is applying for integration. The first one is enrichment, in which we are enriching the data model from one domain with the information from other domain, or we can convert between those. For example, if we have BIM model, we can convert it to GIS, or maybe we can combine them and integrate them into a unified model, or maybe some researchers also, they use linked data approach and semantic web in order to combine the data and then also to create the 3D layers and to make as a foundation for digital twins. So regarding enrichment, most of the papers, they are using IDE, which is application domain extension. They are extending CiTGML and GIS to include some features in the BIM side. In my own initiative, actually, I tried to enrich the IFC model with the geospatial information, specifically IFC 4.3, that's under ISO revision now, and I used IFC annotation for that. Originally, the predefined types were very confusing, actually, and I got contact with the Building Smart. Unfortunately, they took my suggestions and they changed the predefined types to be more aligned with surveying, specifically with geospatial surveying information. And secondly, I found out that most of the BIM viewers or IFC viewers in the market cannot view points or geospatial points. That's why I was in contact with the Blender BIM. Thankfully, they took this consideration into their code and they updated their code, and now you can use any surveying information or surveying drawing and visualize it using IFC. So you can use IFC as the main format in BIM environment without needing for a specific format for geospatial information. And hopefully soon it will be automated, so you can just import the data and it will convert it to IFC. Regarding conversion, I found out most of the literature are using commercial softwares, and most of the conversion are from IFC to CiTGML. However, most of papers is suggesting that there is information loss, either the semantic loss or geometric loss while conversion. Regarding combination, using this method, we are creating a unified model from CiTGML and IFC, but the disadvantage of this method is we are creating a new starter, so we cannot view it using the viewers in the market right now. And finally, using linked data, we're all familiar with Web 1.0, which we're using hyperlinks in order to connect documents. Then we have Web 2.0, which is the web page that we are using. And then we have Web 3.0, which is semantic web. So we can represent our IFC or CiTGML in triples, then connect these triples and create a model from it. However, the disadvantage of this method is that the initial implementation of this technique can be very slow. So the BIM mandate in Ireland and digitalization of Ireland, these two initiatives suggest that we will have more BIM and digital models coming into the governmental side. So it is important to take advantage of those models and create the digital infrastructure from it. And 3D layers can be used for surveying purposes. And also, according to the latest boundary report from Society of Chartered Surveying, they suggest that BIM can be used for doing restoration in complex environment, complex buildings and multi-story buildings. So this is the procedure that now we are following in Ireland, and this could be the future using 3D layers. And finally, it can be used for valuation purposes also, so to calculate the gross external area, internal area, and zoning. So in conclusion, I say digital twins has potential for solving numerous problems. 3D labs is the foundation for digital twins. Integration of BIM and GIS play a crucial role in creating 3D labs. However, the integration is complex and mostly it is application dependent. And as far as I read from all literature, a combination of different BIM and GIS probably is the best solution and depends on the application. Thank you.
Okay.